Okay, well, welcome to the current session that we're providing. A little bit of background before I introduce Larissa. So the use of road salt in our country is something that I began studying when I was at Carleton University, fourth year. And my research was the effect of road salt on sugar maples. And it just so happens that the property that we've been living on for 50 years when we came here had 10 very nice sugar maples as road trees. We have lost just about all of them now to road salt. And so I was interested in the impact of road salt on aquatic environments. And so with that sort of information stimulus, I contacted the Ottawa Riverkeeper organization to see if they had any information that could end up being a presentation for CACOR. And lo and behold, the answer was a strong yes. And so with a little bit of background, Larissa Holman volunteered to be the presenter. And one of the things that she's pointed out is that she has a very strong feeling and wanting to help a stronger insight of rivers and watersheds as a way to engage people with people and encourage action that protects water and waterways. She has a BSc in environmental science from Concordia University and a master's in resource and environmental management from Dalhousie University. So with the background that you see on the screen of the content of the presentation, I especially am very interested in hearing what Larissa has to say. So over to you, Larissa.
Thanks very much, Phil, and thanks everybody for joining us today. It's going to be a bit of a meandering conversation because Ottawa Riverkeeper has covered a number of different threats to the river and rivers everywhere. And so we will definitely spend a bit more time on road salt than other ones, but I wanted to share some of the other work that we're doing. So as Phil mentioned, my name is Larissa Holman. I'm the Director of Science and Policy at Ottawa Riverkeeper. I've been working at this organization for just over 7 years. I'm in my 8th year, and we are a fairly small team of 15 people, and we work across the entire Ottawa River watershed. Because we work in the watershed and we work very closely with Algonquin Communities when we're out doing field work, I wanted to, of course, acknowledge the fact that we are working on the unceded and unsurrendered territories of the Algonquin and Anishinaabe, the Anishinaabe Algonquin Nation, and that they are the traditional and ongoing stewards of this land and water. We also, as an organization, like to recognize that the colonialism has had a profound impact on the rights of Algonquin people, and that there is an urgent need for meaningful actions that truly confront this legacy. For those of you who are not familiar with the Ottawa River watershed, it is twice the size of New Brunswick. The headwaters in our Lac des Outaouais, which is the northeastern edge of the watershed, and they flow westward towards Lake Temiskaming and then take a fairly dramatic turn and then head south easterly towards Lac de Montagne by the island of Montreal. The river itself is 1,270 kilometers long, and its flow varies substantially throughout the year, and we'll spend a minute or two on flow regime when looking at the Ottawa River. But just to give you a sense of how powerful it is as the largest tributary to the St. Lawrence, there have been times during heavy flood seasons where the flow of the Ottawa surpasses the flow coming from the Great Lakes. And so it can be a fairly significant contribution to the St. Lawrence watershed. As an organization, Ottawa Riverkeeper works across the watershed. We try to work collaboratively our intention is to bring solutions when having meetings. We don't try to be adversary, but we do base all of our decisions using science-based evidence. And so we are strongly rooted in the role that science plays in trying to understand the impacts of the river to the river, and also that our mission, our focus is on the promotion and protection of the Ottawa River and its tributaries. And so that is generally the lens that we bring when making comments to various different policy issues and development and whatnot. As some of you overheard when I was about to share my slides, is we act as a watchdog or a guardian of the river, and that's mainly done through our pollution hotline. So we just received a call from someone who has spotted someone doing some work along the shoreline, moving sand to the riparian zone and creating a road. And it's known that this person does not have a permit, so I passed it on to my colleague to follow up with the provincial organization responsible, and hopefully they'll send out someone to enforce the regulations that exist. Quebec has really fantastic regulations. Enforcement becomes a challenge in the rural parts of the watershed. And then also we work across jurisdictions. The Ottawa River forms the boundary between Quebec and Ontario. It also is, I believe it's 200 municipalities in the watershed. There are many Algonquin communities. There's federal jurisdiction as well as provincial jurisdiction. And so it's a very complicated space to try to implement regulations and policies. And that's one of the reasons why it so desperately needs better attention from individuals and from organizations such as Ottawa Riverkeeper. And lastly, I'll just mention that Ottawa Riverkeeper is a member of the Waterkeeper Alliance, which is an international organization, and that we are not primarily funded by any one party. We receive some government funding, but we are not government funded. And so as a result of this we have a variety of different funding sources, we're very keen on maintaining our independent voice, and that's a big part of how we accept donations and the work that we do. So, as I mentioned earlier, I'm the Director of Science and Policy. In 2019, we started a project called the Watershed Health Assessment and Monitoring Initiative. And this initiative looked at 14 different indicators to try and understand the ecological health of the water and of the river. And so there's a lot of pressure sometimes to try and understand, what do humans get from the river? How do humans best access it? How is it impacting our drinking water? But as a watershed organization, our focus has been primarily on ecological health. And when we first started doing this work, we started by doing a scan of the data that is available and design the program over the first 5 years to try and fill some of those data gaps that existed within the watershed due to a lack of provincial monitoring that was happening. And we did that primarily through community-based monitoring programs. How's everyone doing? Am I going too fast, or is this okay?
No, it's fine.
Okay.
Yeah, that's good. That's good.
Okay. After the first 5 years, in May of 2024, we took all of our results from what we were able to compile in those first 5 years and released our watershed report card. I believe I included a link in the material that was sent out to everyone, but it is also available online. And essentially what we did is we took those 14 indicators and combined them into 4 main subgroups: primary productivity, biodiversity, physical characteristics, and human development. And we used different matrices to come up with a letter grade for each one. Now, we don't have sufficient data for each of the indicators, but we have sufficient indicators for at least, I believe, 2 for each of the subcategories. And so at the end, I'll go over some of the recommendations, but the biggest takeaway from this project was, that the the overall grade for the Ottawa River is a C, which is not great. It's better than some capital rivers for sure, but it could be so much better. And that the primary reason why the Ottawa River is in suboptimal health is because of human-driven changes that are degrading the Ottawa River. And so that includes things like climate change, which was mentioned earlier in the conversation. I wanted to spend a moment just going through some of those indicators, just for people to understand a bit more about how we got to this grade, and the care that we take into compiling this information and the different resources that are available out there, and really highlight the fact that for some of these indicators, the data has been readily available from provincial authorities for years. No one has done this analysis at a watershed level. And because there's not that analysis being done, we're missing out on some key understandings of the health of the Ottawa River. And just as a note, when I say the Ottawa River, I generally mean the Ottawa River and its tributaries. I'm an equal opportunist when it comes to enjoying rivers. So it can be the Gatineau, it can be the Des Moines, it can be the Rideau. They all flow into the Ottawa. They're all part of the watershed. And so they're all a critical part of understanding watershed health. The total phosphorus monitoring program is the first one that we really started once we had secured that initial funding to do the watershed health assessment and monitoring program. And we started with 16 different sites and 55 samples in 2021, and it's grown to 35 different sites and 150 samples being sent in. We are an Ottawa Gatineau-based organization. That's where our office is. It's in the beautiful River House right on the Ottawa River, but most of the data that we are looking for that are where the data gaps are outside of the National Capital Region. And so we have worked really closely with a number of impressive community scientists that will collect samples for us and send them in. And so all of our protocols include things like, you know, the whole time, how long can they have it in their fridge before it needs to come back? Sending things by mail. We're very dependent on things going by mail. And so every time there's rumors of a postal strike in the summertime, we get very nervous because it's going to completely upend our sampling protocols. But you can see in the map, those red dots is where we have collected samples from. And so you can, I don't know if people are able to see my cursor, but Lake Temiskaming is an area of interest because there's quite a bit of agricultural area up around Lake Temiskaming, and similarly in the Renfrew area as well, because there's not as many samples collected in that location. With those results, as well as the results that we've gotten from community scientists who report algal blooms, we see a tight correlation between where agricultural lands, total phosphorus values, and algal blooms all line up. And so it's no secret that if you have a higher percentage of agricultural lands, you're likely to have a stronger concentration of total phosphorus in a water sample from a freshwater stream. And then looking at where we see algal blooms lined up with that very nicely. It's not in this map, but we've seen it it's in our report card, that correlation. I think it might be the next slide. As well, you can see here, there's the tributaries. So the South Nation has some of the highest percentage of phosphorus, and the Gatineau as well as the Bon Cher. These are all areas that have some agricultural lands within them. And so again, not a big surprise to see those higher percentages of total phosphorus in those subwatersheds. Up next is a program that we've been working on invasive species monitoring. This is a bit of an older slide. We do have data from 2025, and the number of observations continues to climb. One of the key takeaways for this one is it's only really after I'd say 2017, 2018, that we start to see the spike in the number of observation of invasive species in the Ottawa River watershed. And below that are the number of different species. Now, we only look at a handful of species. We're looking specifically at invasive species that impact aquatic ecosystems. So they either have to be something that lives in a freshwater environment or is located on the riparian area, and so would have an implication on the overall health for the aquatic ecosystem. Just for interest's sake, because who can miss an opportunity to talk about invasive species? Above is a picture of purple loosestrife, which is the most reported species that we get. It's really easy to spot, and so people report it all of the time. Below is a type of zooplankton, the spiny water flea. It has this long spiny bit along its end, and so it's replacing the food source that is available for fish, and fish cannot consume it in the same number. So it's having a very terrible impact on fish populations where it's present. But it is like, it's the size of an eyelash, and so it's very hard to find. And so it's one of the harder ones to report, and yet it's really critical to know where it exists. This map shows you the number of observations that have been reported for invasive species. And one of the projects that we're doing, actually there's two projects that we're doing this summer around invasive species, has to do from the work that we've done previously in compiling this information. This data is taken from our own Survey 123, but we do not get, I guess, like hundreds of reports every year. iNaturalist is a source that we use. It's a open source, crowd-sourced place to report species of interest, and they have experts who can verify it. So it's a really trustworthy data source, as well as provincial resources such as Surveillance in Quebec and EDNS maps. There's some invasive species map reporting piece in Ontario. And so we take all of that data from those open source sites and compile it so that we have a better understanding of where invasive species are being reported, and of those 15 different species, which ones are being reported where. And as you can see from this map, most of them are reported in the Ottawa-Gatineau area and in the southern part of the watershed. And so there's two questions that come out of this piece of information, which is what we're trying to address this year. Is it truly that there are more invasive species in the southern area? In some ways that would make sense. There's a lot more people, they move around quite a bit, they're taking boats and fishing gear, they're dumping their aquatic plants into stormwater ponds. That is happening probably more in the southern part of the watershed and the northern part, but that doesn't necessarily mean that there is that there aren't invasive species in the northern part. So is it that there's an over-reporting, so it looks much worse in the southern part, or is it true that there is that many? And if so, then what does the concentration of invasive species look like? And then the other part of it is, what are we missing in those other areas where maybe not as many people are reporting? Again, it doesn't mean that the invasive species aren't there. It could be that there simply isn't the same outreach happening in that area or the same number of reports. And so we have two different projects that we're working on this summer to try and address both of those questions. One is on Ontario, where we're doing mapping of areas that have observations of some of the more difficult to remove invasive species, and mapping those so that we can provide that information to other organizations who would do work to mitigate the presence of those species. And then in Quebec, we're looking at really doing a lot more promotion and education about invasive species. We created a whole series of quizzes for people to just be more aware of what's happening with invasive species in their region, and why it's so critical to report them if they're observed. The next one was another one that was quite surprising, and this could be considered a contaminative emerging concern. The results were quite surprising in the Ottawa River. I'm going to just skim over it in this presentation because I do want to spend a bit more time on the road salt and another one of interest, which is PFAS. But we do have a full technical report that we've put out, and I believe I shared that in some of the context. But if anyone's interested, please let the organizers know, and I can share that as a PDF if need be. So mercury is another one of the indicators that was raised that would be good to have a better understanding of what the concentrations look like in the Ottawa River watershed. And so we completed this analysis using fish consumption guidelines. To be able to get mercury data, you can use water samples, but that's a very transient piece of information because depending on how much flow there is and the time of year, mercury levels will be different. Fish, because they live within that water body, will be consuming the mercury throughout their lifetime. And so it gives a better indication of the severity or the concentration of mercury, and particularly methyl mercury, which is the one that is toxic to all organisms, fish and humans equally. So we looked at fish consumption guidelines. It was readily available data. It took a little bit of maneuvering to get the data from both Quebec and Ontario, but we did get it. And our scientist, Liam Nugent, I think crunched over 35,000 data points to get to these understandings of what mercury looked like in the watershed. When doing this analysis, we looked at the entire watershed, but we split it into 3 different regions based on the geology. So there's the Southern Ontario region, a primarily agricultural area. There's the southern half of the Quebec province, and then there's the upper reach of the Ottawa River watershed. I don't think I have a map of, there you can see the dark blue area, which includes some of Ontario, but the purple area is all Quebec, and the light blue is the more agricultural zone. And that was because through researching how methyl mercury may be, what might be the drivers that why we're seeing the values for mercury in the area, geology plays a really critical role. The Ottawa River watershed is made up in the Quebec side of primarily the Canadian Shield. The Canadian Shield has a boreal forest. It does not have, the geology does not have a lot of alkalinity in it. It doesn't have that buffer for acidic conditions. There are a tremendous amount of dams in the Ottawa River watershed, both very large dams, but also smaller dams, and wetlands and beaver dams and all sorts of, the topology is low lying in a lot of areas. So there's quite a substantial amount of wetlands, and all of that helps to create a condition for mercury, which is a naturally occurring element, to transform from mercury, which is not necessarily that toxic, to methyl mercury, which is quite toxic and bioaccumulates in organisms. And so I just want to show here we looked at 4 main fish species. They're the most popular fish species for anglers and fishers, and that's why we focused on those 4. Please don't ask me the 4 of them. I'm not going to remember them off the top of my head, but lake trout and walleye were 2 of those species, and then there was 2 more who I'm completely forgetting, probably a bass and something else that's completely delicious, and people would love to fish it for all sorts of different reasons. And what you see here in the charts on the bottom are what the methyl mercury concentrations look like for the most common species by the mercury concentration, most common species by region, sorry. And the red line is the Canadian guideline of 0.5 parts per million. And as the fish become larger, from small to medium to large, you see that, oh, they're here. There's lake trout, northern pike, smallmouth bass, and walleye. You see that these fish species are accumulating more and more mercury within their tissues. We also were really curious when we were doing this report. We sent it out to our watershed health committee to get some feedback on it. And one of the questions that came back was, wow, those numbers seem really high. Is it better or worse than what's happening in Lake Ontario and Lac St. Pierre? Those Lac St. Pierre and Lake Ontario are known to have industrial sources for mercury. And so it seemed like a good comparison. And so again, you can see here the small, medium, and large fish size. This is for walleye. Here at the very beginning, we have the Lac St. Pierre region. This is Lake Ontario. And then these are the 3 different regions for the Ottawa River. And so time and time again, the fish species in the Ottawa River have a higher parts per million of concentrate of mercury in their fish tissue. This led to all sorts of various questions. There are not point source pollution for where these fish consumption data was coming from. Many of them are remote and isolated lakes. And so I'm happy to get more into that later on if people are interested, but I'll leave you with that cliffhanger of things that really caught us off guard and led to some further analysis to try and understand what's going on in that scenario. The next piece here, one of the other parts that we were interested in trying to understand what might be happening in the river system and trying to understand its health has to do, of course, with flow. A river system has a variable flow depending on the season. And so we really wanted to make sure to take a look at how flow might be impacted over time. To do this work, we looked at the any of the water gauges that had an average flow of more than 10 meters cubed per second on an annual average. And so that limited the sources of data that we were using, and that they needed to have at least 30 years of data. And the reason why they needed 30 years of data is because that is how climate research is done by the World Meteorological Organization. And if we're going to be looking at impacts on a watershed that is not just year to year, that's there's way too many varieties, like variables that would come into play with that quick turnaround. 30 years would give us a sense of what might be happening from a climate perspective. And so what you see in front of you right now is the flow regime for the Ottawa River. This is at the Britannia water gauge. It's from 2023 is the mid blue. The darker blue is the historical minimum, and the historical maximum is the light blue. And this is the completely normal flow regime for the Ottawa River. Because of the way that the Ottawa River is sort of like it spreads across this south to northern region, we get this very fast high peak in early spring as the lower tributaries melt. The reservoirs typically are empty during the winter months near the end of the winter, and they hold some of that melting water in the northern region. And then once those are full, there's a second peak that usually goes higher before everything is melted and then the water levels drop. I'm just going to take a drink of water. The problem with longer presentations is your throat gets really dry. And then the water levels, can you find a small water? My sister is here to assist me. Then the water levels drop off and stay relatively low for the summer months. And then we have a second sort of mini flood period in the fall, once all of the leaves drop off of the plants and the plants stop absorbing the water. So the ground becomes saturated. And so those fall rains actually cause water levels to go back up again. From our data, what we noticed was that the spring freshet, as it's called, that initial high flow of water, has started to creep earlier into the year. And so it's happening a little bit sooner. But also very interestingly to me from a aquatic ecosystem perspective is that in the later spring, when or sorry, the late summer, early fall, when it's really hot and dry, what we're seeing is that the low levels in the Ottawa River and in some of the tributaries persist for longer periods of time, which can have some implications on watershed health or the aquatic health. Okay. And the last one, the slide around the watershed report card that I wanted to share has to do with land use and land cover in the watershed. We are very fortunate in the Ottawa River watershed. 77% of the watershed is forested. This creates an incredible buffer for the health of streams. It's one of the key indicators of how healthy is a river system is how much forestry there is. And so much of this watershed is forested. Residential areas make up only 5%. Industrial areas is 1%. Agricultural is 2%. Bare and then green, so it's 3%. So a combination of 5 total. We have 3% of wetlands, and then some forest activity every year. And so that creates a great buffer for the watershed. And then lastly, what was not included in the watershed report card as one of the 14 indicators, but was definitely something of great interest, had to do with contaminants of emerging concern. Ottawa Riverkeeper has done work on microplastics. We did a big project with Dr. Jessie McNamara from the Carleton University around microplastics. We've taken a great interest in PFAS, per and polyfluoroalkyl alkyl substances. We've done this project on road salt, and we continue to be interveners on radioactive waste when it comes to what might be happening at both sites within the watershed, such as the Chalk River facility, but also with national policies around how the government is creating policies to address non-fuel related radioactive waste, which up until a couple of years ago did not exist in this country. I see there's a whole bunch of questions. I don't know if it's worth stopping to answer some of them or if I should just keep going.
We're used to having our questions all at the end, so just keep going.
Amazing. I will just keep going. I will persevere. Okay. So road salt, the original reason why Phil reached out. So for anyone who might not know about our road salt program, I'm going to talk a bit about the program and some of the things that we've been finding with it. Our road salt program is limited to urban areas because that's where we see the strongest impacts of road salt. And it has changed over the years depending on what we've been finding and what we've been learning about what might be causing it, what different solutions there might be, how to best address it. So it's been a very it's been a program that's been very responsive to the questions that have been coming up as we've been working through it. So we began this program 6 years ago, I believe. And we wanted to understand the impact of road salt on biodiversity. We wanted to have a better understanding of, I'm jumping ahead. Why were we interested in understanding road salt? So road salt, chloride in road salt is very persistent. It doesn't degrade. It hangs out in an ecosystem once it's been introduced. It can reduce the biodiversity of aquatic animals. And particularly we were interested in road salt because road salt is toxic to aquatic organisms quite quickly. And so it can really have a devastating effect on urban streams. We started looking at and wanted to better understand the concentrations of chloride in local urban streams. We were hoping to identify hotspots or moments where road salt is highest. And we wanted to use this data that was being collected to really start to raise awareness for residents as well as managers of larger properties and municipalities on the consequences of oversalting. And so to be able to do this project, we actually started this project by mirroring what was happening from the Milwaukee Waterkeeper. They were very generous in sharing their road salt program and sharing their protocols. We made some adjustments to it to fit how our community science programs had been running, and started to do the project that way. We worked very closely and continue to work very closely with community scientists at local streams. Our staff does not collect this data. It is all collected from volunteers who are trained on a protocol and are provided with the equipment that they need to collect the samples. The samples are now collected 2 times a month from December till April, and then some of the community scientists continue to collect a sample once per month throughout the summer. And that we use a program called Survey 123 for our observations and the values that they collect to be submitted so that it's very quickly compiled and able to be added to our existing data sets. This is what the equipment that we use. So the blue and white piece of equipment is a conductivity meter. We have switched away from lab tests to using these strips that provide very accurate concentrations for chloride within 10 minutes of the sample being collected. And those come along with a grid that helps you to decipher what those numbers mean in terms of chloride concentrations. The work that we have done around road salt has not only helped to inform hundreds to thousands of individuals every year in the Ottawa-Gatineau area, but also more broadly than that is there's been a new pilot project by the city of Gatineau, and we assisted in testing for that project where they have ecological neighborhoods where there is no salt applied throughout the winter, with the sole exception of when there is a ice rain event. And that we have been involved in the training programs and sharing of data with the city of Ottawa to highlight the need for city contractors to be considering the ecological impacts of road salt and to maybe be a little bit more judicious with their road salt use. For those who are unfamiliar with road salt, it becomes toxic for aquatic organisms after 120 milligrams per liter. It's considered chronically toxic after that amount. So an organism needs to be exposed to it for a few days in a row before they start to see an impact of the chloride. And then acute toxicity, sorry, this slide is in French. Hi, we're a bilingual organization. So acute toxicity is 640 milligrams a liter. And that means that even a very brief exposure at this concentration can have a fairly significant impact on aquatic organisms. Some of the organisms that are most heavily impacted are really the smallest ones. So the zooplankton, the small organisms, the smaller insects and bugs that provide that base, that foundation of the food chain for those larger organisms later on in their lives. So having those ones heavily impact just removes that important food source for fish and amphibians and other organisms. The sampling locations are here on this map. It's a little bit hard to see because we've layered all sorts of information on top of it. But this is just, highlighting the different ways that we've tried to approach understanding this issue. So the locations, sometimes it's about what does the population density look like, and is that impacting the chloride levels? Is it the flow of the stream? Is it its location close to a major highway or a main throughway? And so are those roads salted more heavily than some of the more residential areas? What does the impact of individuals versus a municipality look like? And our approach has really been that everybody has a role to play in road salt reduction, and municipalities are just as responsible in their road salt application as individuals. The biggest difference is that municipalities also have that health and safety aspect, and so we've tried to work really closely with municipalities to encourage them to be to have a more thorough approach to their road salt work. I will say that the City of Ottawa has done some really interesting and forward-thinking pieces to try and reduce their road salt, but there's definitely always areas for improvement. And when I say the City of Ottawa, I'm not including OC Transport, just in case anyone is wondering. We know that they oversalt at a rate that is unbelievable. So to get a sense of some of the results, obviously results are going to vary based on the type of winter we're having. If there's more snow, if there's more ice rain events, if there's colder patches, if it's a mild winter, that is all going to have an impact on the amount of road salt that is applied. But this is just to give a sense of the range of the data that's been collected. We initially had a correlation between chloride levels and concentration and laboratory chloride value. So we wanted to make that distinction between them. That's what the blue and the green is. The green is the estimation based on conductivity results. The blue is the laboratory results. Now that we've moved to those test strips, we'll be able to use those every time someone takes a sample. But what you see within this slide is the fact that the average amount of chloride within urban streams surpasses the chronic level every single time, and it is often above the acute toxicity level. And so it's a very discouraging recognition of the pressures on urban streams. We wanted to better understand what this looked like throughout the year. And so we see that, and this is why people sampling throughout the summer was really helpful. We don't have as many data points, but we still have some. And so we were able to see that even in those summer months, while the concentration of chloride dropped, it still remained above that green line of chronic toxicity for many of the locations that we were sampling. And so that persistence of chloride becomes really obvious, and how that is going to persist throughout the summertime is something that we've started to share more and more in our social media. And so we put together some recommendations around this. The municipalities and large property owners, they need to take advantage of available resources to ensure road salt application is effective. They need to have road salt management plans and regularly update them. That there needs to be an identification of areas that need to have restricted application of road salt. So for example, where there's an infiltration area for groundwater is a perfect example of somewhere where road salt should not be applied. And that we would encourage everybody to become informed about appropriate road salt use to reduce harm to local streams. I'm going to quickly go through PFAS, and I'm going to skip over the last piece of information, part of my slides, because I'm going on for a long time. So I do want to spend a bit of time about PFAS, though, because this is one of those issues that is currently the policy around it is being developed and debated. And so per and polyfluoroalkyl substances, also known as PFAS, is a class of synthetic chemicals that are used in a whole slew of products, cosmetics, your nonstick frying pan, the firefighting foams, food packaging, such as takeout food packaging, textiles and clothing. All of these now are likely have PFAS on them, and as a result, it's present almost everywhere in the environment, and really hard to get away from. It can move through soils and contaminate drinking water sources, and because it does not naturally break down, it's also known as a forever chemical. This is the optimistic part, I promise. This presentation gets better after we get through these sort of terrible parts about PFAS. PFAS have significant health effects. It can range from developmental abnormalities, reduced reproduction success, increased cancer risk, and impaired immune function. This is particularly important for aquatic organisms because reduced reproduction success and disease and development abnormalities are one thing, but an impaired immune function or inability to avoid predators is just going to really impact aquatic organisms if anything else is introduced. So they just become much more vulnerable. That also applies to humans. We're, as an organization, there's lots of really great work being done on PFAS and keeping it out of drinking water. We're one of the few organizations that's talking about source water protection, not even letting it into that environment to begin with, to best protect those aquatic ecosystems as well as human populations. And then the other really great part, I'm saying sarcastically, is the fact that PFAS does bioaccumulate, and so we see higher and higher concentrations of it as you move up the food chains, and that includes in humans as well. The current policy with PFAS is that it is actually being decided upon currently by Health Canada and Environment and Climate Change Canada. They just released their risk management approach for PFAS for comments, which closed in 2025. They made the decision to exclude fluoropolymers, which is problematic for many different regions. It's one of the largest parts of that class of chemicals. The government's argument is that it's not well understood and that it's very stable once it's been produced. But for Ottawa Riverkeeper, what we would like to see is the policy being introduced embraces the guiding principles of SEPA, which includes the cautionary approach. And so precautionary approach, which means, putting in place restrictions into something before understanding its full impact needs to be there. And that would mean that fluoropolymers would be included as a classification of PFAS. There was some good things in this risk management approach, and that was that PFAS should be listed under SEPA. It gives it a certain amount of powers, and we're happy to see it there. I just mentioned how we would like to see fluoropolymers included, not excluded, and then that there needs to be meaningful guidelines in terms of thresholds. Right now, the thresholds are not well understood what they would look like for environmental outflows from industry. There is a guideline for some PFOA, which was related to PFAS, and that may be what's used for drinking water. But again, what does that look like for an aquatic ecosystem? Often those thresholds are much higher than what is expected for a drinking water piece, and that urgency is required. So now we have this risk management approach, and so there could be a move by government to start putting in place some of the timelines to transition away from PFAS. We'd really like to see them do that in a much faster and more dedicated way. The last section I was going to talk about was the case for community-based monitoring, but I think what I'll do is I'll save that in case there's questions. It goes into a little bit more about the value of community-based monitoring and why it's such a critical way to add value for understanding what might be happening in a watershed, specifically a watershed as large as the Ottawa River watershed, and how engaging and working with people from across a watershed, regardless of their background, to help collect scientific data is a really amazing way to engage with community, so learn directly from them what their concerns are, and to provide really tangible information that those individuals can then use to share with their network of people. And so we find it to be a really fun and encouraging way to learn about the watershed. It also allows us to have a lot more data come into our research and our analysis. We have over 125 community-based community scientists year after year, and they're just such an incredible and important part of the work that we do. So I just wanted to give a shout out to them. And that's where I'll stop my presentation. How's that? Because I see that it's almost 3:23 and I was told 45 minutes, and gosh darn it, did I go over. So.
Well, that was all just wonderful. Thank you very much. I found it very interesting. And it looks as if our audience has found it very interesting too, because I have 12 questions that have been posted on the chat line. I'm going to start out with Art Hunter, who had a comment very early in your presentation. So Art, you want to go first, and then Ted Manning will be second, and Dave Doherty. Dave, when you're putting together your question, could you combine a couple of them that you posted just so that we can move more quickly? So away you go, Art.
Okay, I guess I really had two things that sprung to mind. One was the impact of wildfire along the watershed, or in the watershed, and potentially even right up to the banks of the river. I'd just like to know what you have experienced with that, and what that really means. And the other one that had sprung to mind was the impact of the route that the river takes, because over geological time, of course, there's been fault lines that have shifted, and I know that Ottawa is in a geological position where there have been tremors, and very deep, and causing some surface motion. And if that has, particularly within the last 100 years, had any impact on the route at which the river takes, and potentially any contaminants. Anyway, go ahead.
Yeah, so I can start with the route, because that one is that's one that I think it comes up, especially when looking at changes in flow, because typically when you have meandering rivers, their path becomes quite dynamic as they're carving out their path. The Ottawa is considered, despite the fact that it has some bends and turns, is a relatively straight river. Its path is carved into some pretty substantial stone, and it's quite deep in some areas. So I'd be surprised if it would be impacted by any of those tremors and smaller earthquakes that you might mention. It would probably take something quite significant to have it change its path. The biggest impact of its route is the fact that is that flood regime that we see. That type of flooding is quite unique, and it has caused all sorts of challenges in terms of the fact that we have those sort of two peaks to the flooding in the spring, and that the duration of the flooding is often misunderstood because of the influence of the northern watershed. And so there's a lot of concern about how flow might be manipulated by different dam operators and whatnot in the Ottawa River. But that is not something that is easily done during the springtime. But because there is this disconnect between what is happening outside of, say, someone's front door in Ottawa compared to what's happening up by Lake Temiskaming, it can become very difficult to share that information in a way that is easily understood. I once was in the Temiskaming Shores area in May, early May, and I left Lake Temiskaming in the morning, and the lake was frozen, and I drove back home to Gatineau, and the water was flooding. And so it was like it's like I went from winter to spring in the course of 6 hours. It was absolutely incredible. So the impact of wildfires has not been well studied in the Ottawa River. Obviously, there would be some pretty significant impact of, say, there was a devastating wildfire and then lots of rain. We'd have a lot of that ash and material flowing into the river system. I think this is a much more problematic issue in British Columbia and in mountain regions because of the slopes. And so and forestry seems to have a much stronger impact on flow in those regions as well. We don't see the same impacts in the Ottawa. We did do a study on this with an external expert, and he found that the forestry practices, and because of the topography of the watershed, it wasn't as substantial as what we see in other parts of the country. What I will say, and this is something that sort of come to mind recently, is that wildfires, the smoke is known to contain mercury in them. And so one of the concerns that I'm interested in starting to explore is how does that deposition of the wildfire smoke into different parts of the country impact those watersheds differently. And I think that could be a really interesting issue to explore as more and more wildfires are becoming a problem in different regions of the country, but also just how far that smoke travels. So I'll leave it at
excellent.
that.
Okay, good answers. Thank you.
So Ted, you're up now.
Thank you very much, Larissa. Very nice. I live half of the year on one of the lakes that feeds it. It's from behind me there at Patterson Lake. And we are one of many lakes that are now pretty well clogged completely with Eurasian milfoil as one of the more recent arrivals. So is this general throughout the watershed, or is it mainly in Eastern Ontario? That's the first question. And to follow directly, is it a coincidence that Ontario puts the most salt on roads anywhere in North America and is the only one that pretty well outright bans the use of studded tires? Those are my two related questions. Thank you.
I'm going to be more useful on the Eurasian milfoil one. I don't have any comment about what's going on with the studded tires, and it's outside of my scope of study. Sorry, Ted, but
okay, don't worry about it. Go for it.
It's an interesting idea. So in our we recently completed our analysis of invasive species in the watershed. And in that report, we do have, at the very end of it, we have each of the species and the map of their observations in place. I do not know off the top of my head if Eurasian milfoil is most common in South Ontario. I know it has caused concern in lakes in Quebec as well. And it tends to be a bigger concern in lakes and in river systems, but it's definitely present in, say, Gatineau River and whatnot. It's very difficult to remove once it's established itself, and it's very easy to spread because even just breaking the plant apart will allow new colonies to form. It doesn't take very much for it to get into somewhere else. So if you run a motorboat through it, you're basically just proliferating.
And also, even some of the birds pick it up and take it from lake to lake as well.
Yes, yeah.
Very safe with it.
Yeah. So, boat washing is a really critical part of that. If people are moving boats from place to place, if there's a boat ramp, having a boat washing station is a really important part. There's lakes in Quebec, in a smaller municipality, that they have a pass system, and you can't go into that lake unless you have proof that you've washed your boat. And so there's different things that municipalities are using in different areas. But yeah, it's a very pervasive one, and it's in a lot of the lakes. And there's not an easy solution, I'm sorry to say.
We're finding that out. We got a 30% coverage on the lake with this right now.
Yeah.
And we're crying panic. But anyway, thank you very much, and go on and answer other people's queries.
Yeah.
So Dave, you're up next. Charlie, if you could also combine a couple of your questions into one, and then we're going to go back to Dave Doherty with another question. So Dave, you're on as of now.
Okay, thank you. Just a clarification, Phil, do you want me to ask several different times or pose all my questions now?
Try to group them together now.
Okay, so these relate both to your presentation and to the previous questions, actually. So the first one is this, and you can provide quick answers. I don't need a lot of detail. To what extent do you suspect that human development, including nation-building projects, has contributed and will in future exacerbate the spread of invasive species?
So human development, definitely people going from place to place, that could definitely exacerbate things. But more important is that people, I think, also need to understand the risks associated with like taking your boat out and moving it somewhere else. That spiny water flea that I showed a picture of earlier on, that's most commonly transported on fishing gear. And so it's things like washing your gear, being aware of what's there, reporting it. I will say that in our findings around land use cover, despite the fact that built infrastructure and residential properties are a very small percentage, it has a stronger influence in parts of the watershed than others. And so that pressure is predominantly felt in the Rideau, South Nation, Gatineau watershed as it is in some of the other areas of the watershed. And so it's not evenly distributed. So despite the fact that it's very small, it has a sort of outsized impact on the areas that it is impacting it. There haven't been any nation building projects submitted for the Ottawa River watershed, so we'll cross that bridge when we get to it. But the large infrastructure projects obviously have the potential to have a strong influence on the health of the Ottawa River. And so we're always keeping an eye out on what those could look like and how to best address them as they come up, and not afraid to say that we're not pleased with a development project as it comes up if it's going to have a negative impact on the river and doesn't need to pass through there. An example would be the bridge that's being proposed in Ottawa. There's a 6th bridge that's being proposed, and our comments were encouraging both municipalities to consider the types of the public transportation systems, such as the tramway in Gatineau and the LRT in Ottawa, before exploring adding an additional bridge. That bridge does nothing to help the health of the Ottawa River.
Yeah, actually, I think you just mentioned 2 nation building projects that happened a long time ago. Main one being the Trans-Canada Highway, but the other one being our railroad system. Anyway,
Yeah.
let me get to the next one.
Yeah.
What industrial point sources are upwind that could have brought mercury via long-range transport of air pollution? In particular, what about the smelters in Sudbury?
So we looked at what legislation, what rules had gone into place for Quebec and Ontario, and there was a sizable decrease in atmospheric sources of mercury coming from Ontario and Quebec. It's in the report. It dropped significantly as legislation came in to reduce those sources. What happens with atmospheric mercury is that it can get really high into the atmosphere, and it can actually circle the globe once or like over the span of 1 or 2 years before it gets deposited. And so the mercury is most likely coming not even from North America. It's likely coming from sources in Asia. And that's really highlighting the need for international agreements and the need for all countries to be aligned on what's being done with some of these contaminants.
Yeah, and I might observe that the levels we're finding in fish now could easily have been deposited in the forests that are in this watershed and then made their way into the lakes and rivers over decades.
Yeah, and definitely we saw there was definitely an uptake of methylmercury in the 90s, and that is likely attributed to the acid rain events of the 80s that allowed more acidic conditions that would permit mercury to be transformed into methylmercury. That has since gone down. Those levels have since dropped. And so even though it bioaccumulates, it does have to be sort of consistently there for it to continue to grow and grow. So
might see another pulse with all these fires though. So the next one is, what proportion of the watershed is primordial forest as opposed to regrowth after harvesting? Any idea? Like 5?
None. I have zero idea. I do not know.
Yeah. I'll bet it's extremely low. I'll just point out that I did make a couple of observations that people can see in the comments and in the chat, and ask this one last question. Is road salt used in the Arctic and subarctic areas of Canada? And how about places like Siberia? I know I have been in many places on the prairies and in northern Canada. It seemed to me they're just not using salt at all.
No, and they don't use it, and I would be very surprised if they use it in the Arctic. We use it in Ontario and Quebec because our climate allows for it. It's not used in the prairies or in Alberta very much because it's too cold. Road salt is only effective until -9 degrees. When you apply it as a brine, it can go colder.
At -18, you get a brine salt, which is even slippier than normal salt. But I lived in Calgary in the 70s, and I did put in a comment about this. At the time, they were using gravel.
Yeah.
Called pickle mix with 5% salt to keep it from clumping. Now, because I would say they probably imported a lot of people from Ontario and Quebec who ended up working for the city. Likely a lot of them engineers decided it was a great idea to start using salt. So that's what they use now. And people's cars are starting to rust away.
Yeah. And their infrastructure is going to start to fail.
The cost in terms of having to repair concrete in Ottawa is hundreds of millions of dollars per year.
Yeah.
Anyway, thank you.
You're welcome.
Okay, so Charlie, you're up next, and Ted Manning, you will follow Charlie.
Can you hear me?
Yeah.
Hi, I really liked your talk. I'm an ecologist, and I used to teach and do river science of various kinds. And we were always hurting limited by not much data. And so I really like involving the public in science of this sort, the way you're doing. And I don't know if you could collect $1 for everybody who uses the Ottawa River for recreation. You'd have a very well-funded program, and I don't know how you could do that. But maybe put a jar in every fishing shop. I don't know.
Yeah.
So I just have a couple of trivial questions, but mostly I want to say I like very much what you're doing, and I'd like to see it as a model used in many other places so that we would get a better sort of overview of conditions and when something jumps out at us, know about it. Do you do other chemicals? I would wonder about nitrogen, nitrate, ammonia, and so forth. And I did a lot of oxygen analysis around the clock, and you can tell a lot if you take oxygen samples. Do you do that kind of thing at all?
So we don't, but we have established a real-time monitoring station at River House. And so there's a multi-sonde there that's collecting data every 15 minutes, which I find absolutely fascinating. And we're looking to turn that into a publicly accessible resource. Right now it's only available through a login, and because you can change the way that the multi-sonde works, we've restricted that.
So
but
if you're ever interested in taking that data and turning it into examining the metabolism of the entire river, especially at different points, you could email me through Art, and I'd love to help you do that.
That'd be great. I just wanted to quickly answer your question about dissolved oxygen. So that's one of the parameters, and most fascinating for me, we set it up this fall, and because it's located on a river that's moving, we saw that beautiful relationship between temperature and dissolved oxygen. So as it got cold, the dissolved oxygen went up, but because it's moving water, it got really high. Like the dissolved oxygen, I think it was like 14, 15, it was quite high. And then as you're making that,
was that during the day or during the night?
That was throughout the whole time, because it was when there was ice cover on, but the water
well, if the saturation is 14.5 parts per million.
And then as the temperature,
just because it's cold.
Because it was cold. It was so cold, and it's moving water, and so it's getting mixed, like it's below the fall, so it's getting mixed up and everything. And then as the temperature rose, there's like the exact opposite is happening with dissolved oxygen, and so we saw the oxygen levels drop as it got warmer. And I was like, this is why we are collecting data at 15 minutes, so we can show that relationship, because it's one thing to say it, it's another thing to have it on a chart that people can play with and move around and stuff. So that's our only place where we collect it regularly. One of the things about the Ottawa that we've learned is it's a very well-mixed river. And even in different parts of the river itself, when we put a multi-sonde down, like a YSI, we have the exact same temperature regardless of depth. They have the same dissolved oxygen regardless of depth. It's a fast-moving, well-mixed river. And so it's great fish habitat. So you had a second question though, I think, or a question.
Well, I did just nitrogen, I guess, and
so we're not collecting for that right now.
Samples of the aquatic insects, macroinvertebrates?
We do. We use the cabin protocol, and we do it in some of the smaller streams. So it has to be a wadable stream. We've been doing that work for the last 4 years. This will be our 5th summer collecting data. And we do that primarily in collaboration with Algonquin Communities, Kitigan, Zibi, Pikwaktagan, and Kabewek First Nation. This summer, I'm going in August with my colleague Elizabeth up to
Do you do it per area?
We do it. It's a we do a transect of the river system. So we do use a kick net for 3 minutes and collect the samples that way. And then we also collect all the stream data that goes with it. So the width of the river, the flow, all of the parameters like temperature, dissolved oxygen, conductivity. We collect a pebble count. So we count 100 pebbles. So this is all the Environment and Climate Change Canada put forward this protocol. So we follow that. And the reason why we chose cabin, because there's also there's the Ontario benthic invertebrate protocol, and there's a Quebec one, is that we wanted this data to be compared, be able to be compared in other watersheds across the country. So using that federal protocol, there's all the same information in there. It's just it's allowing that to be used or shared in different ways.
Okay, love to talk to you about it sometime, but let's let other folks come along here.
You can have a conversation. Which do you like better, a caddisfly or a mayfly? Let's chat.
So Ted, you can ask your
No,
next
I did
question.
indeed ask both questions. So I
But
think
just a
Richard
minute,
and
Ted.
John are waiting, and we have not decided yet whether it's me or well, essentially, whether it's Andrew or I going to give the thanks at the end, because we have not managed to communicate. We're both here. One of us
Okay,
will
well,
say thanks.
So do you have a
is,
question?
so he put his hand up, so maybe that means he's prepared to carry it on. He's now president, so it's his turn.
So I've lost what you were trying to do, Ted. I'm going to move to Richard van der Zaag, and John Hollins will be after that.
Please do.
Are you there, Richard? Looks like no. So John, have you
Yes, thank you, Phil. Thanks for the talk. I first met the Ottawa Riverkeeper, I think, in 2001, when you were out in that nice store on Richmond Road. I see you've moved into the River House, which sounds, if I've got that right, that's wonderful. But my question is, the Ottawa Riverkeeper, I think, is a member of the River Keepers Alliance, involving keepers from many countries. How useful is that? What do you contribute? What do you learn from that? And then I have a supplementary question to that.
Certainly. So being a member of the Waterkeeper Alliance, we became a member in 2003. So we've been a member of the Alliance for over 20 years now. As I mentioned, the road salt work that we were doing is something that we first learned from the Milwaukee Riverkeeper. Our Riverkeepers have attended they have a gathering every 2 years. So we occasionally go to that. I've attended it once when it was in Washington, DC. And so it's an opportunity to learn from each other. Many waterkeeper groups are quite small. They're one individual who works, and sometimes their boat is a canoe. And so we are one of the larger waterkeeper groups. And so we do try to contribute in different ways. But because the organization is very most of the staff is located, like the staff that works for the Alliance is located in the US. Much of the focus is on American policy development and whatnot. Though Laura Rainsborough, who is the Ottawa Riverkeeper and CEO, does sit on the Waterkeeper Alliance board and is the representative for Canada. And so we work with other Canadian riverkeepers. I believe there's 9 riverkeepers in Canada. And so we try to keep that communication going. So we all have, different approaches and different foci, but the work that we're doing with the report card and how we're developing these indicators have all been, assisted by looking at what other groups are doing. These ideas don't come from a vacuum. It's learning from each other, and we share all of our data openly on our open data portal. We also share all our protocols online. And so we've also had conversations with other groups in Canada, including conservation authorities. And we learned from Lake Winnipeg Foundation around their total phosphorus monitoring program. So there's lots of sharing that goes back and way. So I would say it's not just restricted to the Waterkeeper group, but definitely the Waterkeeper group does provide us with some benefits, that larger international scope of what's going on. But also as a member of the Alliance, we have some benefits with it. We are currently getting our ArcGIS license at no cost. But we are expected to have a pollution hotline, so there's a give and take there.
Your, the Riverkeeper is a charity.
Yes.
And the organizations you wish to connect with, I presume, start with the City of Ottawa, other municipalities up and down the river, the provincial government. Do any of those governments help to pick up your tab, or would you prefer that they not, so you don't get messed up by people like Trump?
Well, so we have received funds from the province, both the province of Ontario through Ottawa, the Ontario Trillium Foundation, and we have a harder time getting funding from Quebec, but we have been successful in some ways. Most recently, we've gotten some funding through the Canada Water Agency, so that's a federal entity. But honestly, most of our funding comes from foundations. It comes through grant programs. It comes from individual donors. We have a monthly donation program. We're currently doing a fundraising campaign called the Big River Give, trying to gather $5 million to help support our move into River House, but also give us some security as an organization. And we've reached 90% of our goal of $5 million. And so we're very open to what funding looks like from different sources. And the key part of that is, regardless of if it's industry or government, is that we are able to maintain our independent voice. If some organization is going to say they'll give us money, but we're not allowed to talk about a certain thing, we're not going to accept that funding.
So we just, those of us who make donations at the end of the year, so it's not too long till we file them with our tax receipts in April, we should remember you in December, shouldn't we? Okay, thanks very much.
Please do. Yes, that would be wonderful. We with our community-based monitoring program and all of the work that we're doing, we like to say that we punch a bit above our weight. We really take try to use all of those dollars as best as we can.
Okay, so I actually have a question, and it goes back to
what?
Yeah.
Are you allowed to ask questions?
I have traveled out to BC, where they have fish ladders that allow the organisms to move beyond obstacles.
Yeah.
Are there many fish ladders in Ontario?
So no, there are not. And should we have them? Yes, absolutely. One of the fish that has suffered the most with the lack of fish ladders is the American eel. The American eel used to be 50% of the biomass of the Ottawa River watershed. So as a fish species, it was an enormous presence. It used to be such a reliable food source for Algonquin people throughout the watershed, in the winter especially. If the hunting wasn't going well, they could always go down to the river and grab some eels. The eel population has declined by more than 99% in the Ottawa River since the introduction of hydro facilities. Now, fishing and climate change is also influencing that, but the Carillon Dam does not let American eels into the watershed. Some of them still manage to get past that enormous structure. It's incredible. And once they get past the Carillon, and Hydro-Quebec transfers 400 eels a year. So imagine taking 50% of the biomass of a fish population and turning that into 400 eels a year. It's really not a sufficient number of eels to replace what was here. Chaudière Falls has an eel ladder. There is no eel ladder or fish passage other than the eel ladder at Chaudière Falls. There's none at Schatz Falls. There's none on the Gatineau River. There's none further up from there. There is a fish ladder at Armprior, but they're for American eels. But it's very rare that an eel would get up that far. Every once in a while, we get a report of them in a place, and you're just like, how did they get here? But they used to migrate all the way up past Mattawa. They used to make their way up. Like, there's reports in the Coastal report about how there was just huge populations of them in the Mattawa area. and they are missing from our watershed. And so that is the most obvious direct impact of the lack of ladders in this watershed. Lake sturgeon have also been restricted to where they are between the dams. They can no longer pass from one area to another. And so the lake sturgeon are improving in the watershed, but they're not able to mix across populations because of those hydro facilities and infrastructure. And dams don't have to be very big to have a fairly significant impact on fragmentation. You know, even just a perched culvert can stop a fish from getting into its upstream areas. So I wish there were more. How's that for an answer? I'd really love to see more ladders. It's one of those hopeful stories. I feel like we're getting really close to seeing some being put in the dams, and I'm hoping that it happens before too many more eels don't make it up.
Yeah. So one of the things that I learned about making roads passable for cars is that I think it was New Brunswick did some trials using sugar as ice melters. And
Interesting.
the difficulty of using sugar is that it sticks to cars. And so when they park in a parking lot, you have whole herds of deer licking the cars.
That is such a New Brunswick problem. That's amazing. I love it.
So Dave, do you have another question, or are we going to wrap up now?
No more questions.
Okay, so Ted, you're going to do the thank you?
I think Andrew's turn. If you think he's here, he is. So as he's president now, it's his turn. So I'm going to shut off and let him have the floor.
Okay, I haven't seen a question, so I didn't know he was with us. Okay, Andrew, could you do the wrap up? Thank you.
I certainly can. Thank you. Thank you so much, Larissa. This is a topic that's obviously very local to the Ottawa area, but I'm not in the Ottawa area, and you presented it in such a way to make it clear that it is applications way beyond the Ottawa area, that every river is really dealing with this kind of thing. And it was nice to end on that little reminder that those who have a belief that hydro is the greenest energy we've got has its own drawbacks. Don't ask the American eel about its opinion on that. So anyway, this kind of presentation, I'm reminded, is the result of a lot of really great people working together to capture this kind of knowledge on the leading edge and share it out to Canada and the world. We have our group that's with us today asking questions, but of course, many more viewers will be taking this in online on YouTube. So my name is Andrew Welch. I'm the chair of the board of the Canadian Association for the Club of Rome, which means I do my best to administer the environment that the CACOR team works within, and I facilitate their decision-making process. But I also have this opportunity to not only thank the speaker, but thank you for viewers for joining us and for taking in this presentation. If you enjoyed it, you might consider supporting our efforts to continue this kind of leading edge video programming to join CACOR yourself, perhaps. I think we're getting to the point now where we are presenting one of the largest and most diverse collections of presentations on this kind of really important current environmental topic in Canada, if not further beyond, but I don't want to start sounding like Trump. Anyway, we do have various classes of membership, right from following and being on our mailing list all the way up to being a full CACOR member. So do check it out at CanadianCore.com, which is the address you see there on your screen. The memberships are 100% tax deductible since we are a registered Canadian educational charity. And I look forward to seeing you again next week, or check out the next video in our YouTube collection. Bye for now.